In this video, we are going to look at question 34 from the specimen paper. A parachutist jumps out of an airplane and a few minutes or a few seconds later, they open their parachute to slow down a bit before they hit the ground. Our task is to pick graph of air resistance against time from 5 plots given in the question. So for the first part of the trajectory, the parachutist will accelerate, but eventually they'll reach a constant speed when the force of drag exactly equalizes the force of gravity, and they'll move with constant speed. Just when they open the parachute, we'll see a short period of rapid deceleration from the thrust of quickly opening the parachute and the increase in drag force. But later on, the two forces will again equalize and we'll see a new constant speed. So let's start drawing our graph of drag against time. The weight of the parachutists stays constant throughout the motion, but as we'll see, the force of drag will be changing. In this region where the speed is constant, the force of drag has to be the same magnitude as weight. Then during deceleration, it has to be of greater magnitude, and then again they'll be equal. So let's go through the different parts of motion step by step and draw our graph as we go along. So we see an increase, a gradual increase in the drag force as the parachutist is speeding up, and then constant force when the equilibrium is reached and the parachutist is moving at a constant speed. So we see a gradual increase and then constant drag force, which is equal to the weight. Then just when the parachute is open, we get this massive blow, massive increase in the drag force, because all of a sudden the parachutist has a much larger area due to the parachute. So when the parachute is opened, we get a spike. And now he's slowing down again to constant speed where the drag force will be equal to the weight, and now constant throughout. So we can see that it's constant and it's equal to the weight. And there might be something a bit confusing about this question. Know that the magnitude of the drag force is the same just before the parachute was opened and after this spike, even though in this first part of constant speed, the magnitude of the speed here will be much larger than when the parachute is open. That's the whole point of opening a parachute, to decrease your speed. But that doesn't mean that the drag force is larger. Just think in terms of Newton's first law. If we have constant speed, that always means that the resultant force acting on this parachutist will be 0, whatever the value of the speed. And since the weight is the same in both cases, in order to achieve constant speed, the drag must be the same in both instances. And that's why this shape is the correct one for our question. And in the exam, it was option A.